Back. So we saw earlier the middle value. How do you find the middle location? That is the position of the middle value. If you have n items or n data values, n plus 1 over 2. So if you have 99 data values, so remember that means it's an odd number, then 99 plus 1 over 2 is the 50th data value. So you can find a middle number. On the other hand, if you have an even number of data values, n is 100, then 100 plus 1 over 2 is 55 points. So there is no position called 50 and a half position. You have a 50 position or a 51 position. So you have two middle values, 50 and 51. And you are going to add those two values in those positions, divide by 2. Okay, so that is called mean. Mean is arithmetic mean. Let's see what that is. Sorry. To compute the mean, we add all the entries and divide by the total number of entries. This is what we consider average typically, right? In school, etc. But that is mean. Okay, remember, mode is that number which appears most frequently, median is the middle number, and mean is what we in school called average. What is mean? You add all the entries and divide by the total number of entries. The mean is the average usually used to compute a test average. So, to graduate, Linda needs at least a B in biology. She did not do very well on her first three tests. However, she did well in the last four. So, these are her scores. Here are her scores. Compute the mean and determine if Linda's grade will be a B. What is a B? 80 to 89 average. Or a C, 70 to 79. So we are going to add all these numbers. How many are there? 1, 2, 3, 4, 5, 6, 7. So there are 7 tests. Add them all up, add the scores all up and divide by 7. Sum of the scores over number of scores. So you get 80. 80 is a B. Okay, barely made a B. So even though she got 100 at the end, and actually 98 even, right? There are 390 plus scores, right? And yet the average or the mean is 80. Why? Because the low scores really um, uh, conflict with the high scores. Okay, that's what it is. So she'll get a B. Comment. When we compute the mean, we sum the given data. There is a convenient notation to indicate sum. So here is a notation. X represent any value in the data, then the notation, this is called sigma. Okay, sigma is a Greek letter which represents capital S for us. It's for the same sound as S. Sigma X means add all the x's. So sigma s x reads the sum of all given x values. Okay, so I repeat, sigma x means add all the x values. We are to sum all the data values. In other words, we are to sum all the entries in the distribution. The summation symbol sigma means sum of the following and is capital sigma. Sorry, the S of the Greek alphabet. The symbol for the mean of a sample distribution of x values is denoted by x bar. Okay, so the mean of sample distribution is denoted by x with a bar over it. Okay, x bar. If your data comprise the entire population, we use the symbol mu. Mu is lowercase Greek letter mu, pronounced mu, to represent the mean. So what do these notations mean? X bar, that is X with a line over it, okay, is mean of sample distribution. Mu is mean of the entire population. All right, here we go. So how do you find the mean? Take summation of X, that is, find the sum of all the data values. Divide the sum total by the number of data values. For sample, you call it X bar. X bar. X bar is summation X over little n. Little n represents number of data values in this sample. So if you are looking for mean of a sample, you use little n and X bar. If you're looking for mean of a population, it is capital N and mu. Okay, so they mean the same thing, except one is for a sample, the other is for the entire population. Okay, next. We have seen three averages: the mode, median, and mean. For later work, the mean is the most important. A disadvantage of the mean, however, is that it can be affected by exceptional values. A resistant measure is one that is not influenced by extremely high or low values. The mean is not a resistant measure of center because we can make the mean as large as we want by changing the size of only one data value. Now, this is very important. See, the median remains the median even if there is one, I don't know, $5 million house. But the mean will change. If there is one $5 million house in an area where houses go for say 100,000, that one million will definitely increase the mean. Okay, so you want something called resistant measure, that is, it's something that's not influenced by extremely high or low data values. The median, on the other hand, is more resistant. However, a disadvantage of the median is that it is not sensitive to the specific size of a data value. All right, what does that mean? Even if there is $100 million house, the median doesn't get affected. Okay, a measure of center that is more resistant than the mean but still sensitive to specific data values is the trimmed mean. A trimmed mean is the mean of the data values left after trimming a specific percentage of the smallest and largest data values. So you still want a mean, but you don't want the extreme values, very high or very low. So you need to trim off some of those. We'll come to trimmed mean in our next video. Until then.